We must be careful when calculating areas under curves when some of the curve is below the x-axis. If we look at the area between y equals x cubed and the x-axis from -2 to 2, well, from our previous example, we might discern that this area is 4, and so is this one. But when we did the integral from -2 to 0, we got -4. The negative is just because the curve is below the axis. Think about the value of y is equal to f of x there. It's going to be negative. So when we do f of x dx, it's going to give you a negative value. But the area itself is actually 4. So this is why when we integrated from -2 all the way across to 2, and we integrated that, we got 0 because the area cancels out. So when part of the area is below, we need to be very careful because it's going to cancel. And this is especially important when you have a situation like this, because this little loop here will be subtracted from the big loop up here. So what you're going to need to do is do an integral from here to here, say a to b, and then a separate integral from b to c, at least if you're doing it manually. There are tricks on your calculator. So the integral from -2 to 0 of x cubed dx gives a negative result as the area is below the x-axis. The integral from 0 to 2 of x cubed dx gives a positive result as the area is above the x-axis. Because of symmetry, the absolute value of the two integrals is equal. That's the 4's. And then the integral from -2 to 2 of x cubed dx is 0, as the area below and area above cancel each other out exactly.